For a long time, we believed we had the universe figured out. We were told it was about 13.8 billion years old, a precise number, comfortable, stable. It came from our best equations, our best observations, and decades of careful work. And for years, no one really questioned it. But lately, something hasn't been sitting right. What if that number isn't wrong because the universe changed, but because the way we measure time itself might be incomplete? What if the universe is much older than we think? Not because the Big Bang never happened, not because physics is broken, but because our cosmic clock might be off. To understand why this matters, we need to go back to how we measure the age of the universe in the first place. We don't have a cosmic calendar. We don't count years the way we do on Earth. Instead, we look at expansion. The universe is expanding in all directions. Galaxies are moving away from each other. The farther they are, the faster they appear to move. By measuring that expansion and running the equations backward, scientists estimate how long everything has been moving apart. That rewind leads us to a moment when everything was incredibly dense and hot. The Big Bang. From that moment until now, the math gives us a very specific age, about 13.8 billion years. For a long time, everything seemed to line up with that picture. The cosmic background radiation matched predictions. Large-scale structures appeared roughly when expected. Stars and galaxies evolved more or less on schedule. It was an elegant story. Until new observations started to arrive. When astronomers began looking deeper into the early universe, they expected to see chaos. Small, messy, undeveloped galaxies, loose clouds of gas, structures just beginning to take shape. Instead, they found something unsettling. Galaxies that looked mature. Massive structures appearing surprisingly early. Well-defined shapes. Unexpected organization. According to our timeline, these galaxies shouldn't exist yet. There simply shouldn't have been enough time for them to form. At first, this was treated as a minor anomaly, a small tension, something future data would probably smooth out. But the more we looked, the more consistent the problem became. Different methods of measuring the universe's expansion began to disagree with each other. Measurements based on the early universe didn't match measurements based on the nearby universe. The difference wasn't small enough to ignore. And it wasn't random. It was systematic. This problem became known as the Hab-Bull tension, and it raised a deeply uncomfortable possibility. What if our model of how the universe expanded in its earliest moments is incomplete? When something like this happens in science, there are two options. Either the universe is behaving in an impossible way, or our assumptions about it are wrong. And increasingly, scientists are leaning toward the second option. Because when we look closely, we realize something important. We don't directly measure the age of the universe. We infer it. We assume that the rules governing expansion today also applied in the same way billions of years ago. But what if they didn't? What if the universe expanded differently at the beginning? What if time itself unfolded on a different schedule? If that's the case, then rewinding the universe using today's rules would give us a distorted result, like trying to measure a journey without knowing the speed changed along the way. And this is where the idea of an older universe begins to emerge, not as a wild theory, but as a quiet consequence of questioning one assumption. If the early expansion was slower than we think, then reaching the size we observe today would require more time, a lot more time, which means the universe could be significantly older than 13.8 billion years. There's another layer to this question that often goes unnoticed. When we talk about the age of the universe, we imagine time as something smooth and uniform, as if every second since the beginning passed in exactly the same way. But physics doesn't actually guarantee that. In the extreme conditions of the early universe, space and time behaved differently. Temperatures were unimaginably high, energy densities were extreme. Under those conditions, the laws we observe today may not have applied in the same way. Some theoretical models suggest that time itself may have unfolded unevenly during the universe's earliest moments. Not slowing down in a human sense, but stretching relative to later cosmic history. If that's true, then large portions of early cosmic evolution may have taken far longer than our equations currently assume. From our perspective today, everything appears to have happened quickly. But from the universe's own frame of reference, it may not have. This idea helps explain something else that has puzzled scientists for years. The incredible level of organization we see on vast cosmic scales. Filaments of galaxies stretching across millions of light years, clusters forming intricate web-like patterns. These structures suggest a long process of gravitational interaction, a process that benefits from time, more time than our current timeline comfortably allows. And this leads to a subtle realization. The age of the universe is not just a number, it's a story about how complexity emerges. A rushed universe struggles to explain order. A patient universe does not. If the cosmos had more time to evolve, many mysteries become less mysterious. Galaxy formation feels smoother. Star life cycles feel less compressed. Cosmic evolution feels natural. This doesn't mean our current models are wrong. They've taken us incredibly far. But they may be approximations, excellent ones, built on assumptions that worked until they didn't. Science often advances this way, not by destroying old ideas, but by refining them. If the universe really is older than we think, then our place within it shifts. We're not early observers in a young cosmos. We're late arrivals in a very long story, and that can feel unsettling, but it's also deeply human. Because science has never been about comfort. It's been about truth. The Big Bang may still mark the beginning of everything we know, but the timeline between that beginning and now may be longer than we imagined. The universe may not be broken. Our measurements may not be wrong. We may simply be reading time with a clock that was never fully calibrated for the earliest moments of existence. As new observations continue to arrive, one thing becomes clear. The universe is not done surprising us. Its story isn't shorter than we thought. It may be longer, deeper, and far more complex than we ever expected. Sometimes the biggest discoveries don't come from finding new answers, but from realizing that the old ones were only part of the story.